In this video, we're going to have a look at types of decimals. Firstly, terminating decimals. A terminating decimal has a finite number of decimal places. For instance, 1/2, if we put it onto the calculator, is 0.5 and it terminates. Similarly, 3/8 is 0.375. Again, it has 3 decimal places and terminates. A recurring or repeating decimal has an infinite repeating pattern. For instance, 1/3 is 0.333 and it continues in a repeating pattern. We write this as 0.3 with a dot above the first and last recurring digit. There are other decimals that don't terminate or have a reoccurring pattern. For instance, pi is 3.14159, etc. E is 2.718, etc. Our square root of 2, which is known as a surd, is 1.41421, etc. So they do not have a recurring or repeating pattern. So just call them other decimals. So we'll go through 3 examples of looking at recurring decimals using short division. Here, 5/11ths. So putting our calculator away, we have 11 into 5. I'm going to put a decimal point and just add some zeros. I'm not sure how many I'm going to need yet. So 11 cannot go into 5, so I'll put 0, carry up the decimal point and carry over the 5. 11 into 50 is 4 times, which is 44, with 6 remainder. 11 into 60 is 5 times, 55, with 5 remainder, and you can see that we'd be in a pattern here of 0.4545, etc. So we write that 5/11ths is 0.45, placing a dot above the first and last recurring digit. Let's try 5/12ths. 12 into 5. Again, I'm not sure how many zeros I'm going to need. 12 cannot go into 5, so I will carry it over 0 and move the decimal point up. 12 into 50 goes 4 times with 2 remainder. 12 into 20 goes 1 with 8 remainder. 12 into 80 goes 6 times, which is 72. Uh-oh, now we're in a pattern of repeating sixes. So we write this answer as 0.41, and the 6 now has a dot above because it's the recurring digit. Our last example, 27/111. 111 into 27. Again, I'll just add some zeros. I'm not sure how many I'm going to need. Now, 111 can't go into 27. Again, carry up the decimal place. Okay, 111 into 270 goes twice, which is 222, and I have 48 remainder. 111 into 480 goes 4, which is 444, and I have 36 remainder. 111 into 360 goes 3, and I have 27 remainder. Again, I have 27 remainder. So now I'm in a pattern that's going to repeat 243, 243. So we write our final answer as 0.243. The dot goes above the first and the last recurring digit, and because 243 is repeated, It goes above the 2 and the 3. This is our summary of types of decimals, particularly looking at recurring decimals.